definitely said he was coming. system is sensitive or is reactive, then another kind of relation starts. So in this case, we are making kind of this C-type configuration that is immersive. So later on, we will open the rest of the installation. We are going to go in a kind of organic way with you. First, we are going to activate only the front wall, and as soon as we make some experiments, we will go to the complete, let's say, room, and you will witness how it's making a huge difference, because you are surrounded. It's not like video mapping. It's not a flat image showing around you. You can literally feel how physical objects surrounds you, and you can move this kind of reality all over your environment. So yeah, this is, I think, the basic introduction. So now I will give the word to Pete, that is the host of the place. So thank you very much all for coming, especially the people that is here physically, but the people that is connected online from many places in the world. We really appreciate that you give us energy.
Thank you.
Thank you.
Can I ask
Yes,
some
please.
more questions? What's the bit, the color depth, and what's the frame rate?
Frame rate at the moment is 25
25?
25 that we consider enough. I mean, when it comes to the transmission of information, you know, you have to count on many factors. One of the factors is the efficiency of the system. You know? So if you push certain boundaries in one direction, like, okay, we want to make it 100, you know, this basically requires more energy, you know, and energy in this system is basic, because we are playing in a very tiny space, you know. Each one of the microchips here is a PCB board, you know, that is 0.7 millimeters, a PCB board. In that PCB board is a microchip that is nanotechnology, you know. So we have to ensure that each one of these microchips receives the correct information, and it's 120,000 here, right? Sometimes one fails, but it's sometimes, you know. But we are sure that this system is going to receive the correct information. So as it's coming from the top, as soon as it's going down, there is a potential loss. Not potential, it's a real loss of cleanness of the data, you know? So if we push too much in the, okay, let's make it 100, we have to reduce energy in other aspects, like the push of energy down, you know? And for instance, the capacity of making the format bigger, and in this case, is more spectacular. I mean, if you go to 50, people, some specialist people like you is going to say, oh, I see more fluency, or I feel more comfortable about 50 than 25, right? But the mass of the people is going to prefer that it be bigger, you know, because it's more possibilities in terms of space, right? So yeah, it's something that we eventually, let's say, is in the box of things to do, increase the frame rate, but not really dramatically, let's say, important for us at the moment.
Cool.
If you have more questions, please a little bit shy.
About the color launch is 8 bits by channel, so when we blue, so 16 million color. But the curve is very steep, so from black to middle points, it's very steep, so each range is like, you can see that it's jumping.
Yeah.
And then from the rest of the 50%, you cannot see the difference, because then the curves go like that. Yeah.
Right.
But it's full round 16 million color.
Cool.
Okay, so
What do you want me to talk about?
okay, no. Okay, so let's go to the point.
Yeah.
So we are going to show some kind of evolved content on this. So first, we are going to enlight the front wall in full red, so that you can visualize the configuration of the system. So you can stand, I mean, you can be closer if you want. I mean, this is by itself, you know. Actually, we used to do this when we have presentations that we have freedom. We never start the system with a animation, with a volumetric animation. We started like this, because only this is like impressive by itself because it's geometrical, it's beautiful, it's showing the system in its all expression, and it's powerful. You know, the red is our preferred. You know, the red has a frequency, pure red, 25500. Red is incredible. It's create an effect that is not like any other color. Not even a little bit orange, not even a little bit violet. Is pure red. Is like a presence, like a voice, in this format. Because in this wall you have approximately something like 92,000 voxels at the moment, and it's volumetric light. So it's not only about how to create volumetric figures that is holographic, or this concept of hologram, like an obsession. This is a lighting system as well. And you can modify the system not only from the perspective of a 3D content creator, but from the perspective of somebody that is using the light to create some environment, to create some emotion, to create some kind of like a different environments that is combining holographic vision and lighting at the same time. You know, at the beginning of the presentation, you see this white platform. It's like a spot, you know, and if you have a bigger system, you can place lights wherever you want, you can move it on the space. It's like having control over the light, you know, and in the future, as soon as the resolution increases, you will have even more power about what is going to happen on this. This is evidently only the beginning, and we hope that in 5 years we can have much. This year we start the process of the new model that is going to be Dragon 03, and it will have a consistent, much more functionalities, and especially more resolution. So if you have more resolution, you have more control, you know, basically about what is going on. And you can create spheres that is literally behaving like a three-dimensional spots that is traveling on the space. You can give different type of brightness to the figures, because you can not only play with the brightness of the voxel itself, you can play with how much feel is, if you, as an example, can you put a human body, please, Francois?
Yeah.
Now we go to the volumetric side, to the as you see, this is a simple animation, like a usual Mixamo thing. But in this case, the feeling is totally different. You are perceiving a real volumetric object from any angle. If you look from the top, you will see the top of the head. If you go down, you will see the inside of the legs. And
how many layers of depth are we looking at right now?
at this moment, every planet has 20 layers in deepness, so you are looking at 40 layers. And if you look from here to there, you have 80 layers from in set
Size,
And how many
here.
How many pixels are we looking at right now?
Every panel has 6,000. So I would say activated voxels by this body should be something like 5,000. No more than that. No more, maybe 35,000. So there is some, you have the noise ready in the setup?
Yeah.
Okay, so there is some things, you know, one of the, let's say, particularities of this system is that some stuff that is insignificant or just boring or just too conventional in 2D formats, here magically is totally different. You know, there is one example that is in Resolume. I think if you use Resolume frequently, there is an effect that is called noise. You know, noise is just like kind of blur, but a splitting of particles, like little dots. I think nobody uses it, but here it's different because you have three-dimensional noise. And it's, again, please?
Yeah.
It's pretty even more. Yeah. So you have this kind of random particles that is, each one of the dots is behaving in a different way with a absolute control of the gamma color, and then solidifies. So the way to embrace this format is much more easy than you can imagine, because technically it seems to be very complex, blah, 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 it's the technology, innovation, whatever you want to call it. But indeed, it's coming back to basics. It's coming back to the times when making a cube was like amazing, you know, in 3D, the times that just watching an animation of somebody walking was like a technological super achievement, you know. It's coming back to the brutal origins, you know. So there is a kind of pretension from very, very specialist people that because I know how to manage perfectly TOS Designer or media, Unity, whatever, then I have the capability to manage this format from the content point of view more efficiently. It's totally wrong. You give this to a kid, and it's going to instantly make better content than most of us. Because we are pretentious, you know, okay, I will do something really, really impressive because I cannot show that I don't know or I'm not an expert. Wrong. The best is to try the most simple things that you were trying when you were a kid in photo paint or whatever primitive program that you use at the beginning, and you feel like, okay, this is my circle, because I discovered how to make a circle, you know, and in 3D, oh, this is my sphere because I created a sphere. Now I want to give some properties to this sphere, but it's starting from a sphere, not starting from ray trace, super complex whatevers, you know. This format works exactly the same. As much as you complicate your mind, it's going to refuse you. As much as you simplify and remember the times that you started to create the process, it's going to be more efficient. Okay, so we have a little reel that is showing different stuff of the format, and then right after the reel, I invite François or Xiaoyu to follow on the deepness of the software properties.
these are still tricks to, it's not really volumetric in a way, it's not really a real hologram, if I would say. You don't have this kind of energy like we're having here right now. I mean, of course, after my talk, or when we have time in the middle session, I encourage everyone to come to this side and just feel the energy. It's really magical. So a little bit theory of the background I was thinking about is I was really interested in the research of the mathematician and entrepreneur. His name is Stephen Wolfram. He is the founder of Mathematica. I'm not sure if you guys are familiar with that. And then one of the idea he was trying to emerge from his theory is our space discrete, or is our space continuous? You might think, oh, there's the atom, and then atom has a core inside, there's electron, there's photon, you can keep diving into it. But we really don't know what is space. There's a bunch of different theories, but this is kind of representing a different type of reality, especially considering software like Touch Designer and or Houdini, which I use a lot. We don't have lots of 3D software that directly deal with point. It's weightless, scaleless. I mean, of course, you can do p-scale, but as a creative side, you can really sort of manipulate each individual voxel here instead of using isometric or different tricks. So in a second, we will show a piece I work on that translates audio wave, your voice or anything, just audio as vibration, using touch and GLSL shaders to create the semiscope effect, and then in 3D-dimensional space. So it's really a good format naturally, because you feel the energy of each light here as if you're feeling the vibration and the waveform in natural space. This is a really, you might think, when I start to implement my touch work to this format, I was thinking, I want more resolution. I want to have more manipulation. I want to have all kind of control. But instead, it doesn't not always work the way I want. So actually lower rise and then more impact, more contrast, probably something that does not look really cool on the screen because it's computer simulated. In a way, this is more, I would say, my humble opinion, closer to reality. So just embrace this format. I think we'll all have some time to implement your work into this format. And that's my perspective.
Thank you.
Yeah.
All right, so I am Tommy Etkin, I also go by Tech. I'm going to be teaching tomorrow's section. So my kind of story with volumetrics is there's an architecture studio, an Arduli studio, that I've been creating long-term installations with for many years now, and they put together a concept for an installation for the Oklahoma City Convention Center's lobby, where they have big things hanging from the ceiling with these LEDs spaced out. There are these metal bars between them and so on. And so they designed that, but then they realized that their content workflow isn't going to work because traditionally there's an animator there who makes this really meticulously rendered Cinema 4D content that usually we just display on a screen or a panel of some kind. But that doesn't work when you have a volumetric grid of LEDs. So I had been working for a while on a library called ATK, which some of you may be familiar with, but the goal of that was to enable people without knowledge of GLSL to write ray marching shaders. So it kind of provides a touch designer feels like touch designer interface of wiring up objects into a chain to create a scene. And so I've been working on that, and I realized that the logic involved in that and ray marching is all about moving points through space and kind of checking the conditions of the scene at each point along the ray. I'll get into more detail about this tomorrow, but if you have a volumetric grid of LEDs, you know where all the points are, so you can just sample the scene at those points. So this workflow that was kind of developed for like a very different application translated really well into volumetrics. So I developed some content there, but it's like it's high up in the ceiling, and it's like not, so the viewer is pretty far away from it. It's much lower resolution, so we kind of worked with a lot of like sweeping wave patterns and kind of like things that would have impact, when you were dealing with brightness and space and not so much like detail and volume. And so I gave a presentation on that at the Touch meetup back in November. I met Danilo and Francois, and they started telling me about this amazing thing that they have. I didn't quite understand what they were talking about, but they invited me out to Las Vegas to experiment with the setup, and so I tried developing some content for that, and it works pretty well. It's a very different approach than one Francois is going to show you today, but I'll be getting into more detail about that tomorrow.
Hello guys, we're happy that so many people show up for first workshop. So it's been many years I've been working with Daniel, building this volumetric display. So the software engineer head of it. So I manage all the control system, all the software around. So most of the things that you will see later was programmed by me. So if you have any question on that, it would be great to share together. So my past, I've been creating video games since I'm 12 years old, kids, and messing up with electronics since my young age. So I come from video games industry, creating VR experience before I met Danilo. So I'm pretty passionate about electronics and programming. So it just happened. We just happened to meet in Sweden doing my double master degree. So it was quite a crazy adventure from the beginning, because it was just a tiny prototype in the middle of China, and they invited me to come over China while I was still in university. So I decided to jump and quit everything to start up this crazy adventure together with really shallow vision that we didn't know, since there was no market for that, if it's going to work. So yeah, we're pretty glad that after the pandemic we're still here surviving. So right after that we have a little break and work together. I will explain you how you can project your creation and any types of projects with the designer, but as well how the video formats works, all the possibility of simulation, of creation through test genre. So yeah, very glad to be here with you, and cannot wait to share more together. Yeah, that's about it.
Thank you.
Okay, so after the introduction, we are going to make a little break for whatever you want to do. Before of that, if you have any question, that can very important for us is to have your feedback, and especially at the first time that you have contact with the format. We know that there is a lot of questions, so please ask anything that you want that comes to your mind. If we know the answer, we will give you.
Cool.
Any question now?
Yeah.
Yeah. Please.
Have you played extremely loud music with this system? Is there any audio interference whatsoever?
You mean if we have direct interaction with audio?
No, like vibration.
No,
from audio.
if you were a DJ in the center right there,
Yeah.
this was inside of a dance club,
Yeah.
and it was loud as fuck,
Yeah.
would it have any impact on the visuals?
No, vibration. It works. It's the same for any electronics. You know, is there is
I don't know.
vibration, there is movement, and if there is movement, there is increasing the possibility of something disconnect. You know, but basically on the top is working in a mechanical way, same than LED walls or something like that. We have Ethernet cable coming in, Ethernet cable coming out, power con coming in, power con coming out, PCB board inserted. So we before every installation or every show, we make sure that the components are just well plugged. That's it. Especially in these cases, that is a massive vibration. One time we made an installation in Riyadh, in Saudi Arabia, that was in a truck. So the whole structure that was 3 meters by 3 meters by 3 meters high it has to be levitating, you know, it has to be floating. So the structure was literally on the top of a huge truck in a pyramid shape, and it was moving, so it was extreme.
Why did it have to float?
Yeah, it has to be
Why?
because gravity is,
Yeah, but can you not fasten it like
sorry?
on the bottom? Can you fasten it on the bottom to like stabilize it?
Yeah, it's a logic process. You know, it depends on the situation. If you don't have wind or kids, especially the top one enemy of the dragon is kids. You know, enemy, let's say, from the structural point. It's the best friend, but the worst. You know, so if you have conditions that is not going to be too much direct intervention, you know, it's okay to think about. But this is solid. You know, even you can put your hands inside, and nothing is going to be messy. You know, if you don't have this fixing point in the bottom, you will have to have somebody all the time like swiping and swiping and swiping and swiping. Yeah. Mm-hmm. Anybody else? Yeah.
Have you run this with like heavy haze or fog? Does it do something cool?
Yeah. Actually, the first prototype, we were in Shenzhen in China back in 2016. And it's the first thing that it's like fog machine in the background, you know, dramatic effect. It creates something, yeah. It creates some atmosphere, but I will think about other elements, you know, that is maybe has been more spectacular and efficient. One of the most spectacular was the flat LED screen in the bottom, you know, because normally you have 50 by 50 panels of LED flat screens, right? It's kind of standard too. So eventually we put like a base LED screen in the floor, you know, fitting exactly with the dimensions of the installation, and create some kind of connection in between the two realities. So there was a sphere coming, as an example, a sphere coming in 2D, you know, coming from the bottom, and then bloop, like a tree past the dimension to 3D. And as an example, we use this kind of catwalk, and the steps were illuminated and creating waves in the 2D screen, you know. So basically the brain is like even more excited, you know, because it's like, okay, there is a resolution that is part of the whole, you know. It's like an extension. It's not like okay, the 2D is there and the 3D is there. It's creating a combined reality in between the two elements. Another pretty nice feature is to combine the display with DMX controlled through Touch Designer. You know, in Touch Designer you can put together in one patch the Dragon and DMX control and video control and basically anything that you want that is digital, you know. And the combination of these factors and the synchronization of these factors through Touch Designer is something tremendously interesting to explore. We have a laboratory in Ibiza in a club, in a small club, and there we had the chance to experiment with the combination of DMX systems and the Dragon, and you can do literally crazy things, you know. Some experiment that we are making is, okay, imagine that you have one spot in the back corner of the room, you know. In Touch Designer, you can create a common environment that the volumetric, as an example, this walking woman or a face or a head or whatever, is connected to the spot.
Physical, yeah, physical.
Yeah, in a way that if the spot illuminates the display, the three-dimensional figure appears consequently with the position of the light and the color of the light. So this is mind-blowing, you know, because from the perceptual point of view, the people don't know what is going on. You know, they see a spotlight that is illuminating the space in a real way, and suddenly when it comes to the display, to the Dragon, some magical figure appears exactly in the position. So this is like mapping, but with LED. You know, the LEDs are reacting to the position of the light. So this level of exploration, you know, this level of mind-blowing things is what is really the path, I think. You know, not like trying to create complex three-dimensional figures or whatever, is how to make magic with it, how to make clicks in the mind that is, I don't know what is going on there, I don't understand how this is happening.
Okay, so is it designed for the specific LEDs, or if it comes to a larger format, you can just swap them with the bigger size of LEDs, and how about the PC and all that stuff around, or is it just like specifically this product, like?
This obviously the technology can be expanded, you know,
Okay.
to other configurations, but we try to keep the balance in between, let's say, sustainability from the commercial point of view, that we can keep on going basically and keep on investing in advancing, and what can we do? You know, there is a lot of things that is like, we can do this, we can do that, we can do this. But the honest truth is that our market right now is very simplistic. You know, we have modular system. How big do you want it? How many modules? It's 3 meters. If you want something special, it's customized project. That
So
is
at the
made.
moment, that 3 meters high is like the limit, let's say that. Or
It's our main production, let's
Main
say,
production.
because we want to have the chance. For example, 4 meters here is not possible to install. You know, so 3 meters is a very friendly size. You know, it's big enough, but it's not too long to don't fit in. You know what I mean?
Yeah.
We can fit in most of places. You know, 4 meters is, 4 meters is out. You know, it's only really some special places. So I think this year we will have an installation in New York in a new museum. Is hopefully opening in September, and the curator of the museum is a crazy guy. I love him, you know, because he's like, Danilo, let's make this big. How can you make it the biggest? You know, and I said, okay, first is how much money you have, but passing through that we can, let's say, find a balance on that. The limit, let's say, efficient limit that we can achieve today is 4 meters. Because of the loss of energy, you know. If we want to achieve more, we have to change the
redesign the
redesign it up there, you know, because it's going to be more energy, more overheat, you know, like more energy basically. And when you have more energy, you have heating problems. The first one, and second, you have to test again. It's like starting a new path, you know. So the limit now for us efficiently is 4 meters. So with this guy. With Roy, I said, okay, the biggest that we can do is a sandwich, you know? So put electronics on top and electronics in the bottom and join the strings in the middle with silicone bands. And he said, do it. I said, okay, I don't know if we are going to do it. You know, next month in March, end of February, I think. No, March. We will have a prototype of this in Las Vegas. That is going to be because they have this, that I know, a space of 20 meters high, you know? So this structure needs at least 10 meters to go so high, and, you know, the prototype that we are going to build is 6 meters, you know, that with material that we already have in the United States, but it's going to be a sandwich. So I pray that it's not too much troubles, because when we achieve that, the perception of size in this case is a game changer, definitely.
What are the power requirements per module?
In the peak, so if you put like a maximum power full wide, is 400 watts per module. 400. But you never basically do that. You know, even we modulate to be on 60% of the power.
Right.
You know, not necessary to go
Right.
on risky planes. And the average content is in between 90 watts to 150 watts normally. You know,
Pretty efficient.
it's super efficient because, you know, to create a volumetric figure, you use maybe 5%. 5% of the whole system.
Yeah.
You don't need to, you know, I love the red, and even the red is low consuming, you know, because it's a low frequency. So you don't have energy consumption problems ever.
So is it, it's a 2-wire strand?
Yeah,
2 wires.
2 wires.
That's
It's
pretty
like
cool, yeah.
typical cable for your Wallman.
Do you ever have issues with the radio interference?
We prefer to don't mention that too much.
Okay.
You know, something that we don't mention. It doesn't exist.
Yeah,
You know? No, honestly, when in Mobile World Congress in Barcelona, there was the guys, you know, like measuring, you know, like with the the Ghostbusters guys, you know, like with the electromagnetic field, you know, by law, it's got a limitation, you know. But honest truth is, you really have to enlighten the machine. So if you see the guys coming or something, yeah, just get down the content, and it's not it's unharmful, you know. Every phone, even if we put it full wide, is not going to block your communications or cause you a heart attack if you have a bypass, you know. It's a safe machine, it's no problem.
But I was more interested in like radio waves interfering with your sculpture, to be honest.
Thank you.
or something like that, but
Yeah, because it was a big concern at the beginning. You know, we had, by coincidence, our first partner was Satis and Fai, that is a company from Germany, and the guy was like the most paranoid on earth, you know?
Yeah.
He told us, you have electromagnetic, somebody is going to come and fuck you up like sooner or later, you know? And we were super concerned about that, and at the end, it's not really like he said, you know? It's not that, let's say, it's not harmful first, that it was personal concerns, like I don't want that anybody dies, yeah, because interfering with sensitive electronics, whatever, it doesn't, you know. It creates a decent let's say, it's electromagnetic there because every microchip is creating a vibration, right? It's a microchip, so but it's a frequency there, so it creates kind of resonance when it's many close to each other, and it's creating a magnetic field. But somehow it's not interfering in equipment, so it is no problem. And other equipment interfering with this. Tomorrow I think we will have the chance to test the Neuton suit, that is a motion tracker. As soon as it's something connected by microwaves, you know, but it's more like the behavior of additional hardware, you know, that is wireless. If we go wireless, yes, it definitely can affect, but it's not directly affecting the machine. This machine, the Dragon, is more affecting the connection in between the other external elements and this one.
is it possible to rig the modules horizontally? Like, could you tension them?
We never done that, but it's potentially possible, yeah. It's just that gravity is super efficient in that way, you know? It's like making the job. You know, it's always going to be there. Yeah, that's it. You know, but when it comes to tension, you have to simulate gravity somehow to be very equilibrated in the tension points, and it's possible. But yeah, we just expect for a project that somebody demands that.
Yeah.
And said, okay, first time we will do it. It's physically possible. What you cannot pretend maybe is like maybe few modules in like a 1 meter. But if you go much higher, I think it starts to be really an engineering problem. Yeah, like how we fit that, you know.
So once it's modular, you can just space them around in 3D space the way you want, yeah?
Of course.
Of course, with all the, yeah.
Of course, maybe later we will have the chance to show you some examples of precisely this way of thinking. I think the most relevant that we have so far is in Berlin, in a spatial festival in Berlin. We made an installation that was covering as the space of Monum laboratory, that's where we made it in Berlin, was 20 meters by 20 meters. So it's like 400 square meters. And we use only 24 modules. You know? Monum is a three-dimensional zone in space, like a spatial zone. And a spatial festival was about three-dimensional sound. So they had like already columns of speakers scattered all over the place. So with 24 modules, what we made is a central structure of 16 modules and 8 modules in the surrounding area. And we connected let's say, we respected the space in between, you know? So in this case, if there was some object passing from module A to module B, it was not passing immediately, you know? It was respecting
So you can calculate the spacing, yeah?
Yeah, it was like a coherence in between the three-dimensional location of the nine stations that we put. So the central one was more like a narrative. It was enough space. It was 2 meters by 2 meters by 3 meters high. And it was narrative. It was actual volumetric figures inside. And the peripheral ones was kind of creating a immersive impression of three-dimensional entities, you know. So it was like a plane, not plane like a airplane, like a flat surface, undulating like this. You can see how everything is connected, you know, and it looked like a synchronized system. If some object was traveling, you can feel that it's really traveling in coherence with the three-dimensional space. So this is another way of thinking, because the peripheral modules behave like lamps or like chandeliers in some point, but from the other point of view, it was real volumetric content, you know. So you really can break your conventional way of thinking about this is a spot, this is a screen, this is transmitting image, this is producing light, and go to a middle point. It's like, okay, this can produce light, this can be like a total red, and it's going to be like a column, a totem that is red, and in the middle I can create content, volumetric content, or the other way around. Suddenly the peripheral are expressing a sphere that is rotating 20 meters by 20 meters space, and in the middle is just light. Okay, break.
And what's the brightness level of the LEDs themselves at the moment?
The brightness?
Yeah, the level of brightness at the moment that we...
The maximum brightness is 10 candles.
Okay.
Or 10 lumens. So it looks like not too much, but if you multiply by 120,000, you have more than 1 million candles in this configuration.
Yeah.
So it looks like not harmful, one, but if you enlight all, can you put full white, please, Francois?
Not 4 minutes.
Eh?
No, better not.
No, yeah, not full, not full, 60%.
You already tripped a breaker.
Yeah. So the radios was 25 fluid, right?
Yeah, half.
Half split left, right, not front back.
This is pink.
Compressor in the fridge, slow down.
You know, it's not enough with just having providers. You really have to influence on the configuration of the materials that they provide. You know? So this is kind of tremendously important when it comes to the sustainability of a product. You know, you don't have to make it work only. You have to make it durable, strong, flexible, storable. You have to give guarantee that it's not going to break in 2 days or in 2 months or in 2 years. You have to make a solid, stable product. And besides, there is another issues like the import, you know, because then you pass through all the process of building the machine, and then comes, okay, I have to take this machine to the final destination that is not China. You know, there is a market that we have only one installation thanks to Xiaoyu. Normally you make it in China and export it, right? So if it is not passing the customs, all your dream is broken. You know? So at the beginning we had real issues to make the import in Europe, and mainly in Europe it's like they see flight cases and it's something that is capturing the attention of the customs. So we package on carton boxes thanks to Google. That was our first customer in the United States. Before we had to send somebody to the customs and explain what it is because they didn't understand what it is. They said, oh, it's artistic installation, okay. Okay, after 1 week of stuff, you know, because they see flight cases. When we made the import with Google, they said, okay, this is a fixed installation. We don't want flight cases because it's non-ecological, right? So they said, then how we can import this if it is not even a flight case? I don't know, it's your problem. Okay, carton boxes, let's design a carton box because maybe works, maybe not, it's too big, it's too heavy. Okay, let's design a carton box. We designed a carton box, and surprisingly, it passed the customs like nothing, like a no checking, like, okay, carton box, boom, 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 boom. So this is a kind of appliance of experience and creativity too. It's not only about making the machine workable, it's about how to make it fitting in the real world, you know, from every point of view, not only the functional point of view. So,
Why are photos not equal?
sorry?
They're just gonna throw them out,
Oh, because it's temporary?
because it's a permanent install.
Oh, I see, okay.
Yeah. So since then, we import everything in carton boxes. And it's no problem. Any country we import to Middle East, to Europe, to Russia. It was very sensitive to Russia, even from China. They check everything very carefully. The last one that we made is in Mexico. Same result. The carton boxes are magical. Yeah. So this is the metal frame. What we made is a adaptation of a normal LED wall frame because it was ridiculous to try to reinvent metal frames. You know, it's a technology or industrial design that has been there for 25 years or so. So they know what they're doing, and this is super basic when it comes to installation. You know, you are dealing with regulations, fire, whatever. It has to be super safe, you know, and from the other point of view, it has to be understandable for professional people, you know. So this is you can consider this a normal metal frame for LED walls, you know, with little adaptations. So it's got 4 reading points, 1 in each corner, with 1 centimeter thread. So it can, in this case, we are using what you call cheeseburgers. Cheeseburgers. Okay. So this is the Ethernet in signal that is coming from the master controller to the first module. We can split the signal. We used to split the signal even we don't need it, you know, because the master controller is able to manage 24 plus modules, only 1 signal. Every master controller has 4 signals, so multiply. But we used to split the signal just because for some reason one is not working, only part of the experience goes away. And we do the same with the electric power. The power source is power con in, power con out. And the same story. We split the signal in several lines to create some kind of safety system. So this is the cover. No, maybe I can visualize. Okay, it's visible for everyone? Yeah? So in the inside you have two power supply. The reason there is two is because we modulate the signal in between 5 volts and 3 volts to create some kind of Morse code that is precisely what is creating information in the electric signal. It's like 5353, that is equivalent to binary, right? Let's say 3 is 0, 5 is 1. And this fluctuation in voltage is what is understood by the microchips in the strings and the system in general. You have four PCBs, 1, 2, 3, 4. In the first, not the first, the previous model that we used with Dragon Ball, it was only two PCBs that was 50 centimeters length, and the connectors were attached directly to the PCB. And this creates a potential technical problem because if some PCB was failing, then you have to dismantle the entire module. And it is a nightmare, right? So we created this new system that is 4 PCBs that is creating more, let's say, reducing the impact. If so one of those fail, it's only 1/4 of the module that is failing, not the half of the module. And the size is extractable from the top. So you just have to open the cap and extract it and replace it. It's very rare. Well, I think only one time we had to do it, but it was super easy. You know, it could happen with the previous model, and if it happened with the previous model, we have to dismantle. If it is in the center of an installation that is 6 by 6 modules or plus, forget about it. You know, you have to dismantle the entire system. You know, and it's a nightmare, especially if it is like in Riyadh, you cannot fail. You know, if it happens in the middle of the show, you need somebody that solves the problem in 1 minute, literally. You know, and the last component is the receiver card that is called technically slave controller. There is a master.
Master is right there.
And the slave is here. So it's the one who receives the signal by Ethernet cable and trigger the signal in sequence to the rest. The connectors are super easy to, let's say, take off. If in the case of one string is failing, the whole system keeps on working. And in the case of one box that is failing, the entire system keeps on working. So,
It's easier when it's on the ground.
yeah. So, yeah, basically this is a hardware functionality. And now I give the word to Francois that is going to explain the pipeline of the software that we are using for this work. Ready?
Yeah, so we'll start off with the format that we are using, with the video file itself. So, and then how it's managed by Resume to see how we can use different software to as a media server, playback the content, and then design actually real time or record it. So about the video format, I don't know if everybody can see on the monitor. This is okay? Yeah. Yeah? So with the other one, we couldn't take it well. So basically, video formats is pretty standard. So we have two types of video formats. So one type we call it standard, universal.
Ah, sorry. Yeah. Universal. Why? Because so it's a big height and 3 meters depth. So from that big cube, we can just crop the region of interest. So the big advantage of that is like once you render your file, you can reuse it for different types of system. Like here, a U shape or like a cylinder shape. So you just make a mapping from that standard video file to crop out the main region of interest. So as you can see, all the layers, all the slices lie down from top to bottom, left, top, one after the other one, to the right side, and then back to the bottom. So it's kind of like a 3D texture of 120 pixel by 120 pixel and 60 slice. So there is another one, obviously, if your setup is larger than that. It's not actually what is sent out to the video controller. There is a mapping part that is done in Resolume or Touch Designer to cut out the region of interest. So as you can see as well, we have on the top right side like a simulation, and on the bottom the 3D parts, so that allow you to make composition in Premiere, synchronize with music, and see how it's going to look like even before to launch it on the display. So as well, if you want to change color, you can change color directly from the video file. It's a loseless format, so like QuickTime animation, because any compression will be affecting on the Dragon. Since we have so low resolution, if you use a JPEG or MPEG format, you will create some blocks around, and every variation you don't see on the display on your standard monitor, but on the Dragon will be pretty visible, and especially like the jump from from the brightness from 0 to 1 is pretty visible already. So, so in any times we never use any codec that compress the image to avoid any artifact. No, so what I'm meaning, if you want to export your content or create a Premiere composition, you have to export with the codec that's QuickTime animation, a loseless codec, because if not, you see the artifact of the compression of the video file into the Dragon. Yeah, exactly.
The point is that the compression that is invisible to you in the normal display on the computer is super visible. You know, so as an example, you have a line, for example, it's very defined line. When you make compression of the file, there is really unperceptible information surrounding the line, or even randomly in the image. You don't see it. And it's acceptable if you don't see it. Here it is. Here will appear something like a diffuse noise, and you don't want the box in your I explained that you necessary to avoid compression in order to make the box noise the intensity, color, and position that it's supposed.
Yeah, exactly. So then from that universal video, we crop out the region of interest. So you don't really have to do it. It's just, in our case, it's just more practical. So if you want to reuse the same video for other setup. So in that case, we do that in Resolume. It can be done in Touch Designer, obviously, directly. So you can output directly from Touch Designer as well. Just to show how the system can be versatile. So as you see, we have an advanced output in it's a little bit tiny. I'm very sorry. I cannot make it larger. So in output, advanced output, we have a mapping file, a configuration file. So basically cropping each slices and replacing on the final outputs. So we are doing that because so we don't have to change the configuration on the video controller all the time, and all the configuration is done by software. So just make things much more easier. You just have to send a file and apply it in Resolum or Touch Designer, and you don't have to touch the hardware. So we have like a standard mapping on the hardware, and we know what's corresponding, the space corresponding to what, and then you just adapt it. But that step, usually we just provide it to you, or it can be automatized. You can just tell, okay, if it's a simple shape, 3x3 modules, and it will automatically generate that file for you. So it's just to show the example, but we're not going to go that deep. Create your own mapping because that's not really interesting, and it's automatic process. But it's just to say that using a universal video file is so much more convenient because this video we've been using it to so many different setups. So is it clear for everyone? It's like this square, for example, this square is corresponding to this position, and each part is this like a one net Ethernet port on the controller. So everything that display in this region will be corresponding to the Ethernet number 1 on the controller, video controller, and then it's spit out to the first module and then to the second module, and each module know, okay, I have to get this part from the content. So each module is a resolution of 10 by 10 width, depth, and 60 by height. So you can just calculate pitch by 5 cm, since it's a 5 cm pitch. So just duplicate according to your size. So for example, if you have 1 meter, it's 20 pixels. If you have 2 meters, it's 40 pixels. So you can just calculate in that way to know how much resolution you have. But all of that is automatized by the software. So yeah. Any question about that? Yeah.
One of the quality of this is frameless. So so far you could play the video with the duration of glance across.
Yeah.
So instead of of course you can see this as a on its own and the sound is flowing, but at the same time see the voice is spoken nowhere. I mean the noun instructions, and one of the idea we have to change this out. So there's two parts of it. So you can use it not only as a volume but also as quarter. Imagine of course running away from one and then disappear and then turn the other one. We could suggest this continuous of this, which I thought is a good potential of other people probably don't have this quality.
Yeah, absolutely. I have actually an example. No. Do we have some example, Daniel, with like an object passing from one screen to another? Pardon? On the website. Project. Okay. Yeah, so you can see the configuration. We have one central column composed by 2 by 2 by 3 meters, and like 8 separate modules that is like 2 meters away from the center. So the content was mapped with the empty space. So basically, if you have a sphere moving around this surrounding display, it will like have the motion according to it. There was a video, Daniel, on the top. Okay, sorry. Yep, here you can see. So in that case, what we did, I'll show how it was made in TouchDesigner. But basically, we have multiple render engine. It's for each display, so each group of display for the central one and 8 for each surrounding one. And then you can just place this kind of a camera, basically, and you can just place it where you want it. You have a small mapping part, as I show you in Resolu, and then basically you're good to go. Pause? Yeah. Which part?
Yeah.
Yeah.
So this is what I was describing before. The central structure is 2 meters by 2 meters, and there is 8 satellites in the surrounding area that is 1 model, right? So the challenge from the software point of view was to map it consequently. So right,
yep.
So as you can see, this is one plane that is consequently mapped in the structure. So you can create any kind of crazy things with that. You can create the height of the modules, you can create some kind of geometry that is based on the state, you can even create different sizes of modules and still be a consistent system that is connected to each other. So you can just throw some volumetric whatever inside and it will behave. Actually, if you have somebody swimming, it will pass from one module to the other in a correct way. Even if you push imagination, it's something that we still don't do, that we will do next month, is to modelize the structures with DMX, right? So if you modelize the volumetric structure, you can create different heights and play with the image to stay, as an example. So the structure is moving, but the image keeps on the state. So this is, it's totally global, because all that you have to do is equilibrate the position and that's it.
Yep. So coming back on the video file itself, so the big advantage of it, so you can have a version already mapped. Coming back to mapping, they can play from any types of computer, so you don't have to have like crazy GPU. If it's just a loop in a commercial center, for example, so you can just export that and even run it on a Raspberry Pi. That's a good thing about it, and just plug the HDMI and it will run by itself. So the mapped version will look something like that. So that will be mostly, obviously, in that case, we have a small setup. If it's larger, it will just take more space, more video controller. Pardon?
How are you guys sampling space?
Into space? Pardon?
How are you guys sampling space to know, like, how are you guys creating the mapping that good?
So as I say, we have a standard mapping on the video controller, so that we know, for example, the first Ethernet is kind of, you have to think about, is a long line of 12 modules, sit one by side, and you take this long line. For example, you want to have 6 module wide and 2 modules depth. You take this line, this big line, and you just cut it, and like take the other part and move it over there, and there you go with 6 modules and 2 modules together. So you just have to run the Ethernet cable from the right side back to the second row on the bottom. I have some visual, sorry.
How do you get 3D audio? And how are you generating?
Generating is in TouchDesigner. Yeah. For example, here we have some example of mapping of how it's actually rigged together. That's our older version, sorry. But yeah, it's basically you could take a big line and you cut it according to how you place the module in the space. Yeah, and that's corresponding to the mapping here in Resolume and as well in TouchDesigner. So for example, that's a big line of six module, and here we have 7 module. So there is one extra on the side, right? So that's 10 pixels on the side. So it's coming back. You know, so it's like each module is 10 by deep. So you have 4, 8, 10. And then either you can keep running up to 12 modules, or either you can come back and have 6 by 2. So yeah, pretty straightforward.
You're talking about how you're packing the texture, and he's asking you how you're generating.
Yeah, so we'll go to that in TouchDesigner. So I think we are done with the video parts. So let's go to the main part. So basically that's our custom rendering engine that's able to take any types of 3D objects and slice it out and render it for you. So basically you just have to add this in your project, get the outputs. So I'll go step by step. For example, here we have a particle system that's running. So like with some noise effects. Oh yeah, sorry, forget. I should do it directly. So basically, either you can send by SP out the video feed to Resolume, or you can output directly with as a second monitor. So here, outputting directly as second monitor. I just think I have to close Resolume output. Yeah. So our rendering engine is basically taking care of everything for you. The mapping, the displays, and everything. So everything is packed here in volumetric engine. So I basically type which containers containing all the 3D objects. It can be a container, a base, a geo. You just take everything that is inside, the lights, all the objects, and render it out for you. So you type the name of which one you want. For example, just swap over the FBX one, and it will show you a man running. So you can change the position. It's kind of a virtual camera, right? It's like a big box. Instead of being a projection, it's a big box. So let's put it more closer. Yeah, a little bit too much. So yeah, you can just move the camera around, rotate it, change the scale. So that will make automatically the mapping for you. Bigger? Yeah. So you can do that here.
It's 1.2.
Yeah. Scroll it up. The whole. Okay.
Okay.
It's a bit fast, sorry.
So we step through the viewing process.
So,
Are you just working on jig?
So it's a kind of a slicing method. It's kind of the secret sauce. So we, but
You can try to reply it, of course, and it's eventually will happen. But what we really want to do is give the chance to create content for the product. You know, if you want to get quick how we do it, I think it's not a
no, to change the speed.
Sorry?
No, to change speed.
No what?
The speed.
Speaker?
Speed.
Oh, speed. Yeah.
one by one day, but with the particularity in this case that it's organic. So it's not like tac, 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 tac. It's like tac, 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 tac. Reading the camera, the kind of camera moves organically into the space, and we know the formula.
That's not very practical.
Created by the software. But yeah, it's a red line, so the main point is to create content.
Oh, okay.
I mean, it's eventually going to happen, but it's not really sensitive going to
Yeah. Yeah.
Understanding how it works with
it's basically like a
Yeah, this one. Can you just like. Oh, well, it's fine.
Yeah, and it's not yeah, it's mathematical. What is going to happen the way that we are doing it normally is more like a.
You have a special shader that samples a 3D object.
Yeah, it's not. It's like at the end, every dimension contains the previous.
Is it a vortex shader? Right?
No, it's super dumb.
Oh.
The second dimension contains the first dimension. The second dimension, I mean, a line is a consequence of a dot. A triangle is a consequence of a line. A pyramid is a consequence of a triangle, right? So every dimension contains the previous one. In this case, it's kind of a technical application of that. Many bidimensional planes build a three-dimensional reality. That's the basic concept.
Yeah, and we're keeping evolving the rendering engine to make it more efficient with some specialist shaders, especially like in Germany. So we have to have something that with millions of objects or really complex stuff, as well for audio synchronization will help a lot. So yeah, actually we're not we're not so we can respond to question about that, because anyway we will have a new version soon. So yeah. Yeah, more video controller. So that's the standard video file. As I say, it's like 1280 by 960, but we have a 4K version of it. Or if not, you can run multiple video, 4K video together. That's just like a piece of the object, of the render, and all of that can be managed from like either Touch Designer or from the video controller part. Yeah. Yeah, that's a possibility. So if the real-time rendering is too heavy for the computer, you can have the same content playing on two computers separately, and you just send a synchronization signal to the two. And since it's only rendering a piece of the scene, it's working perfectly. It's not using as much as if you render the whole scene in once. Yeah. Yeah. Yeah, 100. Yeah. Yeah. From some, it really depends if it's complex or anything, but you can go really wild. It's like the limits should be like 6 meter, higher than 6 meter cube. Then maybe you need a higher computer, but it really depends the graphic cards and all of that. Yeah, complexity of the scene. So it's hard to calculate to really have a fixed limit.
About the balance between transparency and density. I think that's the...
Yeah, yeah.
We never go to HD for real. We manage files that is very like a low, like a no space in the graphic card. So eventually we hope that we need 2 or 3 computers more, because we will have a gigantic installation that is requiring this. At the moment we are fine. It's low resolution. It's just
with a low resolution specifically for this code.
Yeah. Yeah, coming back to the render engine, so you have a few settings over there. First, so the most important is the dimension. So basically here we have 3.5 meters wide, 3 meters height, and 2.5 meters depth. So right now it's only 1 meter playing, but you can, because we're supposed to have one extra module in the back. So it's like a big cube, there's render everything, and we just take out the middle piece out, kind of just not appearing on the display. So let's just make things more easier. So for example, if I change this value, the dimension up at 1 meter, so we have only 1 meter, so it's render. So that's all about efficiency. You don't want to render stuff that you don't really need, right? The other things is you have parameters to change the density of an object, because since it's only the shell, as you can see, put back the woman, is only the shell of the object that's actually render, not the inside, because we don't have this information on the 3D file, right? Unless you make like an onion with a sphere, within a sphere, within a sphere, to fill it up manually. That's the limitation of this rendering. That's why RayTK come very handy in that way. But you still can adjust the thickness of the shell itself. It kind of creates a deformation, but it really depends of the big, if the object is big, you can really play with that, especially if you have a face, there's only one layer. So you have this parameter depth on Touch Designer that you can just scroll and make it just more thick here. But it's like on the Z-axis, so if you look from the side, it's kind of making a deformation because the shell is too high. As well, we can test with the particles. Or yeah.
This kind of density is out of the object. It's very useful not only from the artistic intention, but from the environmental light conditions. So if you have control over the light in the environment, you can go to pitch black totally. You can create a incredible things only with a few particles that display the shape. Like you are exposed to, I don't know, attention or something, you have intense lighting conditions. One of the solutions is to create more density in the box of the shape.
Yeah, absolutely. So yep, everything is running like real time. You can see I just lock it to 25 frame.
60 or beyond 60.
Yeah, you can put 60. But since we only have a 25 frame by second, you don't need to go higher and use processing power for nothing. So you can record that into directly from Touch Designer. So you just have to make sure you have the right video codec. So types movie, video codec animation, and that will give you a lossless video file. So you just have to connect these whole outputs. So record. No, it's movie. Movie file out. Movie, photo, animation. Let's just put it. Yeah, you can have an alpha channel, but you can take out the alpha channel just by taking out the black part, right? It's pretty much the same.
When we generate video particles, now it's only what we have done, right? It's a video signal. So our generator creates what we call a DMF file, the Dragon Ball file, DMF. So the DMF can be edited or post-produced or managed as a normal video file. So you can take several DMF files and put it in a Premiere So for example, we have one figure here that is literally one layer of the premier, and you can have another layer there, and you can do whatever you want. You know, so in that way, the narrative, the way of thinking about the narrative is completely different than in 2D. Because in 2D, you overlap layers, and one moment is over the other, period. But here you overcome layers with a simple additive that is taken out of black. You have one moment there, one moment here, one moment there, one moment there, by several layers. So this kind of editing mode is completely different than the way of thinking in 2D.
Yeah, so as I showed, I just click on record, just make sure the types and video codec is okay. And we have our video file that we can reuse anytime, put it in Resroom, have a VJ session, make a post-processing effect changing the color, make it noisy, or all of that. To use the post-processing effect, you have to think about that only layer by layer, so you cannot really interact in 3D unless you really make your own custom post-processing effect. Yeah, so that's still the universal, as you saw, universal format, so you cannot display this video directly with other video player directly to the display. As I said before, we have to map it, so there is a mapping part in Touch Designer, so just go in, basically it's the same things that's happening. This case I make it by hand, but you can make it normally is automatic. If it's like normal shape, it's just like we have this two surrounding side. So if it's like a little bit more tricky setup, that is not just a cube, you have to do it by hand, or you can generate it with our tools. But in that case was to showcase that how it's done. So basically crop the section, the region of interest, and place it according to the master controller, video controller, what he understands and which position you have to put it. So yeah, basically it's just cropping each part and placing accordingly, and that's it. Usually we can provide that to you, especially if there's already a setup in place. So you can record from that part the video file. So after the mapping, so let's go back. So now we have a mapped version of the content for this setup. So it only works with this setup, but the big advantage is that you can use any video playback to play back your content, even a Raspberry Pi, so without any technical stuff between. You can use VLC or whatever. So that's a cool part. But it's only for this specific setup. Yeah, exactly. Exactly.
So this each slice is what resolution? Mask resolution?
Yeah, it's much the physical setup. Yeah, yeah, with the side as well.
So what's the horizontal protocol?
So in that case, we have 3.5 meters width, so it's 70 pixel. 3 meters height, 60 pixel. Yeah, and the depth is 20 layers, so 20 pixel. But if you add the side on top of it, so like the black part is the region that's not used, but the video controller is capable to go up to 12 modules. So you just stop after that, right? After the, yeah, after the seven module. So the top part is the net 1, internet 1. The bottom part is internet 2. The first slice is always the most closest to you. Then more you go after the second one is deeper. Yeah, yeah. Almost, almost, because we have one extra. The one extra is like this little one on the side here.
So basically every layer is divided into two when it comes to organic.
duplicating the information in the triad. It's not only duplicating the information times 2, it's every access has a duplication. So if you look at the display from any angle, you will find duplication.
It depends if you're saying what percentage?
It's kind of yeah, it just displays in your normally the first 2 lines was only 1. 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. Little cubes, right? Inside the structure. So what we made is that display which is taking 1 line and dividing into first and third.
So, yeah, to explain that, basically, we always choose the main point of view. So, what I'm most intuitive to do is to take one best view of the station. So, match up to the organ. So, take a look here. So, basically, physically it's 2 layers because the second one here is with offset to the beat, but on the video file, so the first line we put these two together because you see this like square part. Just to make it easier instead of having a mashed up pixel anywhere. So here you can see why the organic makes so much sense because here like this is grid of 5 cm by 5 cm square. If you match up, see this one is exactly positioned in the middle of it. So it's like in the middle of this square you have another one, so kind of give you quite small resolution.
What is the more each axis?
Yeah.
It's exponentially more. So, only for perception is what it's called. Yeah, actually, we saw it because, we had previous model Dragon 3 was particular, and we said, okay, it's really nice, but it's not enough, for example, to put the small related to small work. So we changed it to organic. It's like magically we can read the same amount of boxes because the way is receiving more information. Simple as that.
So, as well, there's a whole anti-aliasing, 3D anti-aliasing. So that's why when the shapes move, it looks so smooth because it's not jumping from one pixel, the object is not jumping from one pixel to another. It's like smoothly, gradually changing color and kind of simulates the movements, anti-aliasing, right? So in that case, like 8 times anti-aliasing. So like you can think about for each pixel, it's like a cube of 8 pixels, 8 voxels, sorry. So yeah, that helps tremendously for the motion. Take a look at VX again.
Clarify so that so you have this physical offset which provides this organic resolution. And does that mean then that the digital file or the data stream that's being sent to the controller is essentially oversampled in terms of you're trying to represent all of those?
Yeah.
It's integrated, yes. The physical displacement is integrated with stuff now. So if we move one boxes like X, Y, Z, we have to kind of counter balance the position by boxes. If not, the image is just destroyed. There is a mathematical formula that the way that we display it is not really random. And it looks random, looks more organic, but it's super calculated. So we have to go through that.
Yeah, so does it have to output the same format? Some of that is just hardware, or like oversaturation
Yeah, we still have to spend some time to make ray decay really matching. But we already make some techniques. But we know there's some step to go further to make it even better, more smooth.
Yeah, you're right. You're right. Figure that out last week, but
Yeah.
the offset every other pixel is
But yeah, basically it's oversampling and then bringing down with 3D blurs, some some techniques that we are working on it. So yeah, basically you can do anything interactive. Here are some sample with audio reactive. We can show. Just have to put the speakers. Latency is really minimal. Later, we have a motion capture suite that really show that that's super minimal. With the Kinect use a lot of processing. Like it's 3 gigabytes of data is coming in your computer, so it's more latency, but it's due to the hardware. But the screen itself have really minimal latency. I forgot the number, I'm sorry. But we can test that together. Oh. Set change. Yeah. I think show you your work is better to showcase the synchronization. It's better to showcase with your work, I think.
Oh.
You know the audio reactive?
Where is it?
Over there.
So you, yesterday, the local racing of this
Ooh.
that we are taking,
Where's the microphone?
is that there is no
Inside the computer.
Oh, just like that?
Just like that? Oh, you want?
But like, where's the microphone? This?
Yeah, no, it's connected too far.
Ooh. Wait, it's not working.
What was the input?
For the first time we tried some audio reactive system designed by Xiaoyu. We're supposed to leave at 11:30. We stay until 3 a.m.
Hello.
So like we never saw before. Literally, the behavior of
Hello.
was different.
Man, shit. I should have that before.
Yeah.
You speak you.
But like, we don't know which one is the.
No.
Can you turn off the music first?
Yeah. Do you have the microphone with you?
Yeah, but it should just work like that, right?
Yeah.
But now. Yeah, so that was let's see. No, that's not a correct input. Is it here?
Yeah. Maybe we have to restart.
Can we do that?
Yeah.
Maybe it's a good time to take a break.
Testing the audio. Maybe later? Just restart, I think. Right?
Yeah, I mean, sometimes you have to restart to,
yeah,
you know, sometimes it was not linking correctly.
So much stuff here.
Ooh, what's that?
Okay, so what is
what is that? Oh, that's not good. That's
before yesterday, the last, let's say, advanced
Speakers?
kind of limit, it was kind of green for us to be able to make the point cloud system.
What's that song?
It was like we have
It's off, everything.
Maybe that?
You are in between the responsibilities, commercial projects, blah, blah, blah.
No, it's a computer.
But the last year,
I think it's my fan.
It sounds like fan is stuck. Can you turn it on?
Huh?
Don't turn off your fan. Your computer is too hot. Yeah. You just don't turn off the fan. Like it's running really heavy. If you turn it off, like
No, it's not that.
Alright.
It's like, what the fuck is that?
Yeah, I know.
Is it speakers or?
Can you do a restart? No.
It's the speaker. Il est
no,
sospecho,
maybe
¿no?
the next 2 weeks, So we said, okay, I understand the intention. The only way to do it is point cloud. Capture point cloud. So it's like a
You want to restart it?
reading the three-dimensional reality and transferring in real time.
No? Yeah, I think the speaker is getting crazy. So crazy. It's crazy, yeah.
I think they're just Q&A. We feel free to take a break, you know.
Okay.
Is it hard if you restart it? Is it hard to...
No. Getting crazy.
Just restart it. Just restart it. That's fine. They're talking.
What?
Oh. Was Unity?
I think it's Restroom, but speaker was not on. Yeah, it was just some crazy noise coming from Restroom, so I just restart.
It's all of a sudden it's like...
Yeah. Point cloud, face scan, you mean? Yeah, sure, the connects over there. Ba-ba-boom.
I can just show mine later. This doesn't matter.
Okay. Oh, I think. Oh, it's open again. Sorry.
No worries, man. Take your time.
So this point cloud system opens the possibility of real actor interaction into the central environment. So we are kind of starting to be in touch with people that is in the other team, like having new ideas about what can be an experience for the public, and the integration of virtual characters in a three-dimensional way is a possibility that we have today. If you put one of these structures that can be 4 meters high and 3 meters by 3 meters, you can make God's presence there, like some gigantic being that is interacting with the actors and with the public at the same time, identifying everything in a three-dimensional way, with the main characteristic and the main difference of this format and other is that we share the three-dimensional dimension, with the screen. We don't, one entity or person that is looking at you from a 3D screen is looking at you and everybody else. There is no identification or discrimination. It's the same for everyone. But here, you can identify people, you can interact with particular person, and eventually you can create systems that is automatically doing that. Because artificial intelligence now is still a little bit diffused. People is trying to use it for weird things, but you can actually use it for identification of people. It's one of the most simple functionalities that is, okay, this is a human, and the human is behaving in a particular way, so the machine can react consequently. So can identify if it's a kid, if it is an adult, if it is Caucasian, if it is Asian, if it is black, if it is women, men, and can identify the emotional behavior. If it is just standing, shy, or if it is very expressive, or if it is expressed curiosity, just raising the hand is a parameter that can be identified into the system and interpret as curiosity. And the machine can react consequently, not only in terms of the content, but in terms of the direction and identification of who is curious, between 20 or 50 or 100 people. This particular individual is curious to me, so I'm going to emotionally react to him. And this is kind of another level of connection with installation. This is the starting of an emotional connection with the machine. Everything. And it has to pass first through art and then through functionality. So yeah,
so they need to have the place you stay in volumetric.
Yeah.
okay. Anybody? Yeah.
Okay. You said play the weight spots?
Oh, looks the same.
Sorry, sorry. Ah. Yeah, you can move it around. Yeah.
Yeah.
Oh yeah, as long as it's in the box, right? Yeah, it's I can make it closer. Yep. Okay. Okay. Yeah. What's happened? Yeah. Disconnect. Yeah. Yeah. We we are recording anyways at the same time, so worst case we can send a record video, you know? Yeah. Yeah. Yeah, okay, let's do that. Let me ask Daniel. Daniel?
Yeah.
Should we stop the streaming on YouTube? Because
So it's not running?
it's working, yeah? Okay. Yeah, yeah, you can stop it. Let you in.
So did your render pipeline have to change a lot to implement this, or is it just
Yeah, you can stop it, one. Then we'll confirm.
This is just the normal
Okay,
functionality
thank you.
of the Kinect Azure camera.
Sure, yeah, yeah.
See you.
It's a combination of cameras. One of the cameras is infrared.
Okay, no, I'm familiar with the point cloud in general. I was just curious, for you to make this work on your system,
Yeah.
were there any